All right, guys, in today's video, I'm going to be showing you a problem with this Tripp-Lite backup power block. This is a special purpose type of UPS, or uninterruptible power supply. It's meant to go inside of a structured wiring box. You can see it has 12-volt outputs over here, and then it's got dedicated plugs along the perimeter for different networking devices. The problem we've got here, I'm going to show you, is when you have it on, it will just suddenly shut off. So let me show you the problem first, and then I'll explain what's causing it. All I've got here is just a simple load, just a battery charger, just so we have a load on the AC side. So I'm going to go ahead and turn this unit on. You can see here it's plugged in off to the side here. All right, so it's got AC power. You can see it'll come on like it normally is. We've got power going to this battery charger, and then it just shuts off, right? If we try to hold it and do a self-test for 3 seconds, it just shuts off. So this looks like a battery problem. You might think, oh, we'll just change the battery, but that's not the case. We already put a new battery in this unit, and what we see with a fully charged battery is it'll run for about a day and a half and then start exhibiting this exact same problem. So I'm going to open it up and show you what I think the problem is and how we go about taking it apart to try and repair it. A unit like this runs about $300 to $400, so it is worth a repair attempt. This is not like your basic computer type of UPS. To get this guy taken apart, there's some screws around the perimeter, these 4 here. Just need a Phillips screwdriver to pull them. These ones around the perimeter and the ones I'm going to show you on the opposite side are all the same length. There are 2 right here above the brand name, though, that are smaller, and they're holding a little bracket that keeps the battery secure. All right, so we can see these little guys are shorter than these ones we took off on the perimeter, so don't get them mixed up. After you do that, we can flip it over, and on the back, we've got these 4 perimeter screws as well. If you've never had this open, which would be kind of surprising after this many years, you would have a piece of a warranty sticker covering this one up, but most of these have been opened at least once since they were new, with the batteries being changed out. And if you just have a genuine battery problem and you don't have a more serious problem, I've done a video in the past on how to change just the battery. I'll go ahead and link that up in the upper right here. All right, these are the only screws you need to remove to open it up for what we're going to look at and test. These 4 here are securing a bracket. We're going to leave that in place for right now. Right behind this power block, you can see there's an indented piece of metal that's going to get in our way of hitting something on the circuit board. So even though this is unplugged, and even though the battery has a problem, it could still be very significant voltage in here, so you want to be careful. We're going to slide this down to get this piece away from that part of the circuitry. Then we're going to lift up on it, and then we're going to wiggle it out, just like that. You got to be careful because the power LED tethered line here is pretty short. Let me give us some additional light. And what we're going to do is we're going to come in with a voltmeter, and I'm pretty sure what we're going to find is that this battery is depleted. And I'll explain why I think it's depleted here. All right, just going to set this up for voltage. We'll come over here and measure on the positive, measure on the negative, and we've got 8.25 volts. And this UPS, like many others from this company and as well as other brands, once you drop down below 9 volts, they shut off like we saw. So why does replacing it with a new one end up after a day and a half in the same situation? We took this one out and we found it depleted below 9 volts as well. When we started it, it had 13. So the problem here is this circuitry is constantly checking the battery and sampling the voltage. And over a day and a half with no charging, our theory is it's a charging problem. It gets depleted. All right, so now to test that, what I'm going to do is reconnect the AC power. Now, Everything we're doing at this point is going to be a safety issue, because the voltage inside of a device like this is enough to kill you. So if you don't know how to handle electronics and AC voltage systems, I would suggest this video is not for you. All right, so now with this plugged in, what I'm going to do is re-energize it, and I'm going to try to see if it'll stay on long enough for us to get a reading off the battery here to see what the charge voltage might be. I suspect it's 0 or below 12, but let's see. Let's see if we can get this to stay on long enough to do that. No, it won't stay on long enough to do that. All right, so what we're going to have to do is we're going to take the power off again, and we're going to put the new battery, or the charged battery, in here so that we can get the measurement we're after. All right, so now with the fully charged battery, if we come in here even without turning anything on, you can see this battery is reading 13.17 volts. Now we're going to turn this on. And it'll stay on long enough for us to see if it's charging. And we're not getting anything other than the battery voltage. So if I was to try and unplug this, I couldn't measure anything because the circuitry is going to detect that there's no battery connected, and it's going to shut the charging circuit off anyway. So what are we going to do to fix this? There's no schematics for this type of product. And actually, you know what? Let me redo that, guys, because I didn't even have the AC plugged in. So we were just measuring the battery. My mistake. Let's repeat this test. Same test we just did. Positive, negative, still just reading battery voltage. All right, so no change in the output, just making sure it's behaving the same as it did when I tested this to begin with off camera. All right, we held this thing down and got it into a test mode, which we didn't want. I don't know if I can get it out of test mode. There we go. All right, so again, how do we go about testing this? Well, no schematics, so we're going to have to do it the hard way. We know that this board here is likely where we're going to be focusing. This board here is used to, between here and here, is just used to filter and smooth out the incoming AC line voltage. This board here is just related to this 12-volt output. It's an accessory capability of this product. So what we're looking for is, if we follow these leads back, we can see that there are a couple of bridge rectifiers that are manually soldered to these two aluminum standoffs. And then we've got a transformer here. There's no voltage regulator on the board on this design. There's some FETs over here on these heat sinks. They're part of the inverter. And there's a couple more in the back corner that you can't see in the shadows. There's a sprinkling of diodes. There's another small transformer back here. So we're going to have to do this the hard way. We're going to pull this out. I'm not going to bore you with all that, but I will show you with how to remove this board, and then we're going to see if we can identify the most likely suspects on the charge circuit for this and see if we get it going. We can't put too much time into it because, you know, it's only worth what it's worth, but it's worth enough for an attempt. All right, so how do we get this out? Well, first off, we've got the AC power removed. We've got the battery removed. You can still sometimes have some residual power on this large capacitor. If we press this power button again, sometimes you can see the LED flicker, just like that. That's because there still was some residual juice in it. So we're going to make sure that that's all depleted, and then we can go about trying to separate this out. going to kind of move over to this side here, and the way I'm going to go about removing this guy, I'm going to try to leave all these connected. We're going to need to take off this bracket that we left in there to begin with, and we're going to need to remove this board. And then if you see down here, you can see there's a Phillips screw in each corner of this board that we want to get out. We can access this one, and the one down here, but we can't get to this one without removing this board. And then we'll need to get this bracket out in order to actually pull the board out. So let's go do that first. And then what we can do with our power while we're waiting, we can start plugging in this is just a sealed lead acid battery type charger, and we'll go ahead and start trying to recover the battery that was in there to begin with. Charge it back up. These little chargers are handy. I'll put a link in the description. You can use them for these kind of batteries as well as others. All right, so we'll let that get going. And now let's take off this bracket. So again, keeping in mind this little cord that we've got tethering the power connector. Now we'll take out these 4 screws here. And that's going to let this bracket drop out. When you get to the last one, go ahead and grab the bracket so that it doesn't drop down onto the board. Okay, so I'm just going to hold this with my finger. Okay, so we got this guy out. Got these 4 that go with it. They're all the same length as the ones we took off around the perimeter of the outside cover. A little piece of paint came off. Now we're going to flip this back down, and we'll take off the one here and here. And that'll give us access to this other little Phillips screw right down there. Just going to kind of fold this guy over like this. All right, and then I'm going to need a longer screwdriver to get in there, so let me switch tools. All right, I'm going to start over here. We'll take this guy out first. And then this guy in this corner next. And then this guy that we got access to right here. And then I think the last one, yep, is right down through here. I don't know if you guys can see. Real bad lighting. Let me grab a flashlight here off the back. Now you can see. So this guy actually has a little ground strap on it. If you notice, for some reason the flashlight is showing up flickering on the camera for some reason. But when you take this guy out, just take note of that little ground strap. All right, so we got all of those off, and that should allow us, unless there's another one that we didn't see, to get this off. Okay, what I'm seeing is that one that we took off at the bottom with that ground strap has got a rivet type assembly associated with it because it forms the threads for one of the mounting screws we removed. So let me show you what I'm talking about. When you're trying to do this yourself, this screw that we took off, it was one of the mounting screws. There's actually a little threaded piece that's part of this ground strap right down there, and that is kind of wedged into the circuit board. So I think I'm going to have to get a plastic prying tool back there to lift that up. So let me try a plastic prying tool. All right, we're going to use this kind of flat piece of plastic. It's kind of an automotive trim type tool. I'm going to push it back in the back corner, see if we can pop that off. Yes. All right, we got that off. Now what's it held by? It's not held there anymore. All right, this is probably as far as we're going to get with this board. We'll have to work with it like this. I mean, at some point, I guess we could choose to just unplug this lead here to the power piece. It's just glued on. It's not anything critical. That'll kind of get this hassle out of the way. Just take note of which side the glue was on because the connector is not keyed, so you want to remember which way it goes. Similarly, well, no, this isn't going to help us because this one is still going to be connected by these lines. I really don't want to unsolder anything that I don't need to. So what am I going to try and get access to with what I just did? Well, right over here, this is the first bridge rectifier setups, which you can see on this kind of square piece of metal, and probably this side it might be easier to see with the flashlight. You can see that there's 4 diodes that have been manually put together to put an old school style bridge rectifier. So why would we start looking at that as one of the suspected components? Well, because when the AC power comes in, one of these is being used to convert it to DC. So it's a possibility that one of these has either one or more of these diodes has gone open or shorted, and that could be part of the problem. Since there's no voltage regulator, I would suspect what happens next is the voltage goes over into this transformer, and then between this transformer and possibly this large capacitor, 12 volts is output that ends up going out on these 2 leads to the battery. It's not a complicated charge circuit, so we should be able to zero in on it pretty quickly. These 2 large heat-sinked MOSFETs I would more suspect to be part of the inverter circuit, which means taking power from the battery and working it back in the other direction to convert it into alternating current. But we'll start with that. We'll have to remove these to test them. I'm not going to kind of bore you with that. So I don't know which is which without a schematics. I'm going to desolder both of these bridge rectifiers and test them out. If they test out okay, then we'll put them back, and then we'll remove this transformer and we'll test the windings in this transformer. We'll also, if that's okay, then we'll move on to testing this capacitor. There's some simple tests we could do that with the board even in this position. I don't think that they're directly related to the charge circuit, but they're easy enough to do. We can put the meter in continuity mode, and then you can see there are a number of just standard fuses here. They start with an FB. Right? And it's easy enough to come in here and test each of these fuses. Looks like there's 2 here. There's 1 here that we'd have to test from the top and the bottom of the board. And I don't see any other fuses, but those are easy enough to test of that style. There's a high amperage style here, totally unrelated to testing, totally unrelated to charging, but while you're in here, it's easy enough to test. Similarly, we can put the meter in diode mode, and we can remove and test each of the diodes. We can also use that to test this transistor and this transistor. So there's a lot of testing that we can do to try and eliminate the failed component even without a schematic. So let me see if I can find out what this is and bring you back. All right, guys, as you can see, I've got it put back together. The only component I found with a failure condition was this power capacitor. It's supposed to be 2200 microfarads at 25 volts. But this guy is reading way below spec. So what I ended up doing is I replaced this, but since I was in there, I went ahead and just replaced all of these electrolytic capacitors. This whole set here that you see was less than $7, and even at that price, I was able to get all either 10,000 or 6,000 hour service replacements, so that'll be a lot better. All the diodes tested out, including the bridge rectifier, all the fusers tested out. So the only thing left I was going to do is this power transformer right here. But what we decided to do is let's just see if it was the capacitor. So I've got it all put back together, and I'm going to do a reading of the voltage of this battery. This is the newer battery, and just sitting here, get this over here where you guys can see it, just sitting here, we've got, whoops, got it backwards, 13.14 on the voltmeter. So what I'm going to do now is I want to see if we're getting any kind of charging now. So I'm going to go ahead and hook up the negative terminal, and I'm going to go ahead and power this guy up, but I'm not going to turn it on. And now I want to see if it does anything different just sitting here. All right, 13.72. So that's higher. That may be a charge voltage. I'm not sure. If you guys are able to see that. 13.73. 7273 doesn't want to make up its mind. So now if I turn it on, just want to get it grounded out here. If I turn this guy on, he stays on now. This up here, you guys can see that LED. So it stays on now, but that's just because it's got a good battery at this point. But while powered on, I want to see if there's any difference in the voltage. Yes. This down where you guys can see this. So it looks like when it's turned off but plugged in, there's like a trickle charge. But when it's turned on, it's pushing out 14.18 volts. So that was it. Most likely, this large capacitor was the fault, but since we replaced all of them here, you know, it could have been any number of these, any one of these, any combination of these. I'm going to go ahead and let it charge up here for a while and make sure it's still acting okay, and then we'll come back. All right, guys, I thought I would just show you how I go about testing these capacitors and point out some things that you need to be cautious of when testing them. So this particular meter I'm using only has a capacitance test that goes up to 100 microfarads. And so if we take one of these capacitors that exceeds that, like this guy here, I believe this guy, yeah, 220 microfarads. And so if we go to try to test something that exceeds that rating, you want to make sure you're doing your polarity correct too, since these are electrolytic type capacitors. It'll take some time, even within the supported range, for it to kind of charge up. Whoops. Kind of let it come unconnected there. Let's get it back. And so, you know, we get these kind of spurious, unusual readings, and then it goes to open link. And that's kind of indicative of what you'll see when it's out of the range that the meter can handle. If we take this other guy that we pulled instead, he's only 22 microfarads. If we do him, he's well within range. And we'll see that, you know, there's a momentary time for it to charge up, but then we get 22.31 microfarads, which, or 37, is kind of floating around there, probably as my hand wiggles. But that tells us, you know, this one was okay. So we ended up having to test some of these with a specialized capacitor tester. Now, that tool, I have this particular one. There's a couple of different ones out there like this. Just let this guy power up. I'll show you how he goes. So now if I take that same one, go ahead and zero this out. Sometimes you get this spurious reading info on here. It's not too concerning, but we'll go ahead and do that. And you'll also see there's like this big sticker on most of these brands that tell you that it's important that you zero these caps out. For these little ones like this, it's fine to just short them out right on the lead here for a couple of seconds. A larger one I would drain down with the voltmeter or with the resistor. And they even tell you on here, you can use something below 100 ohms to do that. So without connecting the leads together, we'll put this guy on here and we can see, all right, now we're getting a good reading, 212, roughly 213 microfarads. So that's still okay. Now, ultimately, in testing all of these between the two tools, it turns out that the reason for our failure was this guy is simply out of range. So it's not like he's failed, but this guy is, I think, the cause. So he's the pair of this other one. So this is another 220 microfarad one. If we put this one on our capacitor tester, what we'll see is it's just kind of flashing some odd readings off and on, and then here we go, 18 millifarads, 34, 35 millifarads, less than a microfarad. It's just jumping all over the place. And so what we see here is this is a failed capacitor. So we can't get a decent reading out of it. Internally, it is just simply failed. And so this guy here is, out of all of these, is the reason that the charging circuit stopped working. Now, we don't see any sign of bulging on this guy. There's no sign of leakage. He doesn't present any visual inspection reason for being a failure. But this guy is the failure. I'm pretty sure the fact that this one was, out of spec is really irrelevant. It's just this guy here. But I'm okay with replacing all of them, because if this one has failed, then all of the other ones from the same supplier at a minimum, which is all of these, have the same supplier and the same date code range. They're all going to fail pretty soon afterwards, so we might as well just do them all. All right, guys, after 5 days of checking the charge and discharge and self-test passing, we finally put this guy back into service, and he's all good to go. So 2016 and still going strong heading into 2026 here. If you got questions or comments, leave them below and I'll try to help. If you found this video helps you get your AV550SC Tripp-Lite UPS working again, appreciate you paying it forward by hitting that like button. And as always, thanks for watching.